So there's a lot of information in constructing the UART, whether it's a controller or the wrapping circuit. So we need to abstract all these ideas using a driver. So we take a look at the header file for that driver, and what we'll see is we have some sort of a register map. It just maps exactly the register map we have, some sort of a mask field, and this mask is necessary because we have packed the R data, the RX, and the TX together. So we need to actually do some ANDing and whatnot to actually just unmask it. And we take a look at the actual methods, and these are actually the most useful things that we use as a driver. Always when you develop, look at the driver, and you will see the methods are the most useful things as an application developer. As a driver developer, you'll have to come up with these, but as an application developer, this is what's important to you. So there, we're gonna divide the methods into two: basic methods and display methods. So the basic methods, we take a look at this set baud rate, which is pretty intuitive. Okay, so all it's doing is actually figuring out what the baud rate what do you want, like basically 9600 or whatnot. And again, the driver should be constructed in such a way that the end user should just set 9600. It will figure out that there's a divisor, I need an equation, I need to divide by 16, and my frequency for the system and whatnot. All of this should be done by the driver. As an end application developer, all you have to do is just like, I want to set the baud rate to this particular value, and it does do it. The other two signals in here are basically to read the status signal to see if the FIFO is empty, if the transmitter is empty or whatnot, or is full before you actually send anything. As a processor, you need to know, is there anything else that I need to read? Before I actually send something, can I actually send something? Is the FIFO ready for me to write into it or not? These are two basic signals. Then I have transmit a single byte, the simplest thing ever. Basically, I want to send this byte, go, and it will actually do all the processing for me and do it. And receive a single byte. It will actually issue all the commands that we need. The other two part of functions or methods that we see in this particular drivers are all display. They're related to the display, and they're pretty straightforward. So one actually displays a single character, the other one here displays a whole string, this one here displays an integer based on some sort of a base, which is 9, which is base 2, base 16, base 8, depending on what you want, and the length of it, without the length, and they're all overloaded functions, so they're all called the same thing. And of course we have, like, we can just send a number without the base and we'll assume that it's a decimal, or we can do it with a float and decide how many number of digits. And there are some private ones, private functions in here, and the private functions basically display string. It just displays a string, and actually it's the base for all of these displays. So taking a look at the basic methods and how they're implemented, one important thing is actually the constructor in here. So in the constructor, you'll see I'm only saving the base address, and I'm setting the baud rate by default to 9600. So by default, you're going to have to just, whenever you instantiate or create an instance of this particular class, or you're creating an object, I'm just setting it to 96. Of course, later on, you can just compute a new divisor, like whatever the baud rate you want to be. Basically, you take that equation that we've seen before, we compute the new divisor, and we just write it into that particular offset. And that offset is actually somewhere here, divisor register. I don't even have to remember it. Of course, I know it's 1, and if I take a look at the header here, I know that this divisor register is actually 1. But still, you see the beauty of actually abstracting ideas and writing them this way. These are straightforward. You're just basically reading something and you're just unpacking it. Okay, so you're reading this particular one and you're unpacking it, you're reading it and unpack it and so forth. And the rest of them are pretty straightforward. You can read them. So I want to just talk briefly about the display one. So the display, as I mentioned a few seconds ago, this is a character, a string, and they're all based on actually the Arduino serial print. Okay, they're very similar, and they're inspired by it. Okay, they're not exactly the same, but they're inspired by it. And all of them are actually based on this particular function. This particular function, all it does, it actually takes some sort of a string, and we know that a string is just a bunch of characters, and each character is just a byte. So we're basically sending a byte. So we're going to go through all the characters within that string, and that's using a while. Okay, and we're going to transmit them 1 byte at a time. Where did the TX byte come from? It actually came from the basic functions in here, and it's this one in here. What does the transmit byte does? It actually, as long as the TX FIFO is not full, as long as the transmitting FIFO is not full, and of course this is busy waiting. If it's full, you just wait. We're just going to write some sort of a data to the right register, which is here, and it will just basically do the rest. The Uart will do the rest, and that's basically how it is. So these are just basically the base, or this particular function is the base for the display. I highly recommend that you take a look at how this is implemented in the uart_core.cpp, basically the implementation for the Uart driver, and especially this one. It's actually really interesting how it's implemented.